Good morning. I'm Tony Paraka, Field Applications Engineer with Coto Technology. Today I want to introduce you to a new line of magnetic sensors based on tunneling magnetoresistance from Coto Technology. These sensors bring significant advantage to product design. Let's talk about the analog output sensor first. So this would be an RR111 or a RR141 type of device. To look at the output of an analog output sensor, let's walk over to the chart and also look at the output from the sensor on the demo board. This is the output profile chart of Coto Technology's analog output TMR sensor, such as the RR111 and the RR141. On this chart, the vertical axis is the voltage output from the sensor, and the horizontal axis is the strength of the magnetic field at the sensor in the direction of its sensitive axis. On the right side is field from a south pole of the magnet, and on the left side is magnetic field from the north pole of the magnet. The green line shows the output from the sensor. What we see here is at zero magnetic field strength, the output of the sensor is at 1/2 the applied supply voltage, which is usually called as VDD. The green line here represents the output voltage from the analog sensor. One thing to note here is at zero magnetic field, the output from the sensor is at 1/2 the power supply voltage to the sensor VDD. That also means the output of the sensor is ratiometric, which means the output varies with the applied power supply voltage as well as the magnetic field. What this profile also says is, as the south pole magnetic field strength at the sensor increases, the output of the sensor increases until it reaches VDD, and then it flattens out for higher field strengths. At the same time, if a north pole magnetic field is applied to the sensor, the output voltage drops from 1/2 VDD towards 0 volts, and then it flattens out at some point of magnetic field strength. The slope of this line is the sensitivity of the sensor. These sensors are available in different sensitivities to address different application needs. With this output profile, this sensor can be used to measure the distance from the sensor to the magnet, because after all, the magnetic field from a magnet drops off as you move away from the magnet. That same property can also be used to measure the rotation of the magnet on an end application. Let's look at this on the demo board, how the sensor operates in real life. Let's look at the operation of the linear or the analog output sensor, the RR141. The output from the sensor is a voltage proportional to the field strength. As the field strength increases with the north pole, the output voltage goes down towards 0 volts. As the field strength from a south pole increases at the sensor, the output voltage approaches VDD. For this demonstration, I'm going to use a 1/8 inch diameter magnet, 1/8 inch diameter by 1 inch long rare earth magnet. The shiny surface is a north pole, and the black surface is a south pole. As I bring the north pole towards the sensor, we see the output voltage starts dropping, as seen by the LEDs shifting to the left or towards lower LEDs. As I bring the north pole to the sensor, as I bring the south pole to the sensor, the output voltage increases, as seen by the green LEDs lighting up. This function from the sensor can be used to estimate magnet position. For example, here's a configuration where the magnet translates with respect to the sensor. As the magnet moves, the north pole and the south pole are presented alternately at the sensor, and the output voltage from the sensor varies in proportion to what pole and what field strength. In the same fashion, this sensor can be used to demonstrate or to measure the rotation of a magnet, such as this round magnet. This is a 1/4 inch diameter magnet by 1/4 inch long and rare earth. The shiny surface is a north pole, and the black surface is a south pole. What we see here once again is, as a magnet rotates, the north pole and the south poles are presented to the sensor, and the output's voltage changes as shown by the LEDs lighting up. So the analog sensor R4141 can be used to measure magnet positions in a linear motion as well as magnet position in a rotation motion. For more information on these sensors, please visit our website www.cotorelay.com. You can download data sheets, application notes, and more information about these sensors. When you're ready to do your product design around these sensors and you're faced with questions about how to optimize the use of sensors, how to select the right magnets, please reach out to us. We are more than happy to work with you. Please send us an email at appsupport@cotorelay.com. We'll respond to you straight away and help you along your way. Thanks so much.